Let's now discuss the basic concept of geocoding. Geocoding is the process of spatially referencing features based on its address to which it relates to the face of the Earth. For example, the GPS unit in your car performs geocoding every time you enter a street address. The GPS unit takes the street address and associates it with road data sets to determine the coordinate that exists at that address. There are two typical types of geocoding: linear geocoding and area geocoding. Linear geocoding assumes that the addresses vary linearly along a feature, which is typically a line. Area geocoding assigns the geocoded location to the entire area that matches the input address. Let's look at an example of linear geocoding and then area geocoding. As an example of linear geocoding, imagine a geospatial dataset that has the center lines of a road. Between intersections, each road segment has a beginning address and an ending address. If we geocode using that dataset, since we don't know exactly where each address is on that block, we assume that the addresses are spaced evenly between the start and end range of the addresses in the block, and therefore estimate where the addresses exist. So, for the example on this slide, this block of Easy Street starts at the address of 100 and ends at the address of 200. We wish to know where the address of 180 Easy Street is located, so we first identify the feature named Easy Street, and then narrow down the results to the block where the input address exists. Next, we estimate how far down Easy Street that address is, assuming an equal spacing of addresses. The major downside to linear geocoding is that the location may be misplaced if the addresses are linearly spaced. The major upside of linear geocoding is that the datasets are commonly and often freely available and are easy to construct. Let's now look at an example of area geocoding. This illustration shows different street segments from address 100 to 500. For each block, it has the address range of 100. Here, the building footprints have been stored in a polygon geospatial dataset, and each polygon has the address of that building. As each building has a slightly different shape and size, you can easily see that the addresses are not evenly distributed along the blocks. With area geocoding, we do not need to worry about whether the addresses are evenly spaced, as we can point to the exact area that the address exists. This is a much more accurate way to geocode than linear geocoding. The major downside to this geocoding type is that datasets are not commonly available and are very expensive to construct.